Designing network segmentation in Azure is key to organizing and securing your cloud environment. By leveraging Azure resources and best practices segmentation pattern, you can effectively isolate workloads, control traffic flow, and bolster security across your network. Core Azure constructs for network segmentation are subscription, virtual network, network security group, application security group, and Azure firewall. Subscriptions provide a high-level boundary for separating resources within Azure. Subscriptions are ideal for creating organizational divisions. Communication between resources in a different subscription must be explicitly allowed. Subscriptions provide a strong foundation for isolating large entities within your organization. Virtual networks offer network-level isolation within each subscription. By default, virtual networks are isolated from one another, and communication between virtual networks requires specific provisioning, such as virtual network peering or hopping through firewalls. Network security groups regulate traffic flow to and from resources within virtual networks. They allow you to create perimeters around subnets, individual virtual machines, or virtual machines groups, and ensure only authorized traffic can pass through. Application security groups operate at the application level and allow you to group virtual machines by application tags. This makes it easier to apply traffic rules based on those tags and streamline the management of network security policies. Azure Firewall is a cloud-native, stateful firewall service. Azure Firewall filters traffic between Azure resources, the internet, and on-premises network. It provides robust security features including Layer 3 to Layer 7 filtering and supports centralized policy management through Azure Firewall Manager. These core concepts cover the essentials of Azure-based segmentation. However, real-world scenarios often demand additional considerations. For specific workloads such as operational technology, additional frameworks like the Purdue model can be layered onto these Azure constructs. Industries like defense may also have unique segmentation requirements beyond standard technical measures. Why network segmentation matters? Network segmentation is crucial to prevent lateral movement within your environment if a component becomes compromised. By isolating workloads and controlling traffic, you limit the reach of potential threats and enhance overall security. Let's discuss few network segmentation design patterns that are mostly adopted in industry from the virtual network perspective. The pattern that you see on the screen includes single virtual network. In such case, all components of a workload reside within a single virtual network, which is suitable for operations in a single region. You can use network security groups and application security groups to secure segments like subnets or application groups. You can segment web and database workloads into different subnets with controls allowing specific communication between them, and you can use NAG and AGs to control the communication. This is the second segmentation pattern. This segmentation pattern includes multiple virtual networks communicating with each other through peering. In this case, resources are spread across multiple virtual networks with communications enabled through virtual networks peering. This pattern is useful when applications are grouped into separate virtual networks or deployed across multiple regions. Subnet within each virtual networks using NAGs and AGs and leverage virtual network peering for control communication. Such type of segmentation used for replicating workloads across virtual networks in different regions or to address business resiliency with explicit peering to manage connectivity. This is the segmentation pattern 3. This segmentation pattern includes multiple virtual networks in a hub and spoke model. In this case, a virtual network acts as a central hub with other virtual networks connected as spoke. Traffic between spokes is routed through the hub, where centralized security controls are applied. Azure Firewall in the hub governs traffic between virtual networks and the internet and provides scalable security as your network grows. A central hub virtual network managing traffic and security for multiple spokes, and each represent different business units or regions. In pattern 1 and 2, default system routing connects workload within subnets, but pattern 3 requires explicit routing through a layer 3 device like Azure Firewall for spoke-to-spoke communication. Pattern 1 and 2 rely on NHGs and AHGs for traffic filtering, while Pattern 3 uses Azure Firewall for more advanced controls and centralized management. NHGs and AHG logs are available in all patterns, but Pattern 3 benefits from Azure Firewall's extensive logging capabilities for traffic passing through the hub. In Pattern 1 and 2, misconfigured NHGs or AHGs can expose public endpoints, whereas Pattern 3's use of Azure Firewall prevents unintended access by dropping return packets from asymmetrically routed traffic. By leveraging Azure's robust segmentation features and applying the appropriate patterns, you can design a network that is both secure and scalable. Whether you are working with a single virtual networks, multiple virtual networks, or a hub and spoke model, Azure provides the tools necessary to maintain isolation, control traffic, and ensure compliance. As you implement these solutions, remember that effective network segmentation is a key to protecting your resources and maintaining a strong security postures in the cloud.